Okay, this will be for Wednesday, March 25th. We've been working on rational exponents, either the rules or the combo problems. What we will be doing here is trying to work so that we can keep in radical form. We'll give some guidelines on how to simplify when it's in radical form. Now we will have that option of taking the radical form if we want to change it to the rational exponent form, but we will be required to give the answer in radical form. So we want to be able to do the simplifying without having to change forms. Again, if you need to, by all means, I will go through processes that we can approach. I'll give you a series of guidelines as we go through. So things that we've seen in the past. We've seen something like this, and early on this was, is it something you recognize? Is it one of those, because it's square root, is it one of the two items? Is it one of two numbers times themselves, or values times themselves? So we'd say square root of 4, we'd say 2. Square root of 36, we'd say 6. Well, with this, when we get here, we don't recognize it as something as a perfect square, but doesn't mean it doesn't have a value. What we did before was we did the calculator value. There's a time and place where that's good. I did that so that we could work on the decimals and the rounding and type stuff. But there's a way to give a simplified answer to this, and we would say it's simplified radical form. It will match the exact value. Okay, so right now this is an exact value, but it's not simplified in terms of what we need. So think of, if we have 4/8, we should be able to reduce that to half, along that same lines. So I worked on earlier when we did those other ones, square root of 36, square root of 49, I took time to rewrite the numbers so that we'd have that power that matched the index. And I continue that practice here. Well, I have square root of 300. I could realize, well, that is really 3 times 100. I can think of these as the square root of 3 and the square root of 100. Now, the next rule that we'll learn, the product rule, it separates those. Well, if I think of it as this, and that will be, and when we get to the product rule, we'll understand it a little more. But we know 3 times 100 is 300. Well, this is one of the perfect squares that we recognize. We know square root of 100, we know that's 10. Now, please understand that that's a multiplication. That's a multiplication, so it's still a multiplication. It is not all of a sudden an addition. Well, square root of 3, well, if that was 4, we'd be able to say 2. Okay, so if this had been square root of 400, we'd be able to say 20. This is an irrational value. Okay, it doesn't have a perfect square. So when we go through, we want to try to simplify in a manner like this. If it's a square root, try to take out any perfect squares that we can. So again, recognition of those will help along, speed things along here. Now this is normally not how you probably represent this. We know this is 10 times that, so we can represent it in this manner. Okay, so square root of 300 is an exact value. 10 times the square root of 3, 10 root 3, this is an exact value as well. This maintains all the decimal places. Now if you take this and you take this and you plug it into the calculator, you're going to get the same decimal value. Okay, so if you needed to get the decimal value to round. The thing is, on the test, when we have this on the next one, test 4 or whatever it might be, I'll ask for simplified radical form. I'm not going to ask for the approximation. So get beyond, well, I'm just going to plug this in the calculator and spit out whatever decimal. We want to be able to do this. Okay, so if we see something like this, be able to simplify it. This is simplified radical form. So we've got some rules of simplifying. Okay, so the first one we'll get in this clip, and the others will approach as we get further along. The rules for simplifying. First one is what we did here. What we want to do, first rule, we want to remove all nth. N is determined by the index. So if it's a square root, I want to remove perfect squares. If it's a cube root, remove perfect cubes. If it's raised to the 16th root, remove anything we can get raised to the 16. Remove all nth powered factors from the radical. Okay. Key word here is factors. Things that are multiplied. We do not want to take things out that would add to get to this. So we don't want to take, say, 49 plus whatever that would add to 300. We want things that are factors. So when we break these up, we're thinking things that would multiply to this value. Okay? And just remember, as we take and simplify, remember that 100, as we go through down the line, we could have done that. That's the square root of 10 squared. Remember we had that phrase, if the power matches the index, take out the base. Just remember, it's still a multiplication. We did not put a plus in between here. That makes it a different value. So you want to continue this process, not just on the numbers, but also on the variables. So first rule, and this is something to always look back. If this is a 2, remove anything that's squared. If that was a 3, we'd want to try to remove anything that's a cube, or rewrite it as a cube. Always look back in. Okay? And we continue that process until we have information where the powers are less than the index. Right now we know this is a 2, correct? This power is a 1. We worked our way through until we had powers that were less than the index. And they'd stay inside. Okay? If this was a 3 cubed, we'd still have information to take out. This is one that is a mainstay. This is one of the ones that I generally, so as I go through and I correct, I have to say rule 1. Okay? You want to know something simplified in terms of radical? This is the one that we want to apply the most. Okay? So we'll do another one. Don't need that. And we'll go to blue. Okay, so one of the things we did in the past, we had something like this. Right? Square root of 36, y squared. Well, we knew that when we did this, again, we could rewrite this as 6 squared. If the power matches the index, remember, this is a 2 if it's not there. If power matches the index, take out the base. So I can take a 6 out, I can take a y out, and remember, that's a multiplication, because that's a multiplication. Now, up till now, we had the nth root of a to the n. We had this that we worried about. And then we also had a second version, depending on whether it was even or odd. Well, these are the two that we're worrying about. Well, this was for even. This was for odd. This will be the sign of whatever the base is. Even, we want to ensure that it's going to be positive. So this was even. So we have to ensure that the variable will be positive. You can slap it around the 6, but absolute value of 6 will be 6. So to simplify, this would be the answer. As you proceed, you're going to get to a point on the test they'll say, assume everything is positive. If we assume everything is positive, we don't have to worry about the absolute value. I just want to worry about taking this information out. So we're going to look for that key line, assume everything is positive. After that, we just want to worry about this process. So if I do this, now that's an odd index for this, the cube root of 81x to the 4th. We always want to look at it, remove all its powered factors from the radical. We want to remove things that we can, in this case, the nth power is 3. So can I rewrite this information to match that index? So basically, can we get it to look like one of these? Power matches index, we just take out the base. Now, as I look at it, what I know is that the numbers are going to be the hard part. Okay, the numbers are going to be the hard part. So I start with 2, I always start with 2, and I start with the index. So I'm going to take 81, I'm going to divide by 2 cubed, which is 8. Well, 81 isn't divisible by 8. If that was a 4, I would start with 2 to the 4th, and I'd divide it by 16. If it was a 5, I'd do 2 to the 5th. This will give me a way to break this down in terms of this. Well, it's not divisible by 8, so I go to 3 cubed, which which is 27. If that didn't divide in, I go to 4 cubed, 5 cubed, 6 cubed, I work my way through. Well, it just so happens that 81 is 3 cubed times 3, or 3 to the 4th. Okay? Well, so basically I deconstructed that number in terms of factors. I can deconstruct this in several ways. If the number is larger, I'd want to break it down in terms of the power rule. I'll show that in another example. Here, I just want to deconstruct it in terms of the product rule. If I have an x cubed, so that power matches that index, well, I had 4, I have 3, I need to remember that there was another one. If that was a 5, that'd be an x cubed and x squared. Now we can do that, but if that's x to the 40, I don't want to do x cubed times x cubed times x cubed. Remember, if the power matches the index, we take out the base. If power matches the index, take out the base. Well, power matches the index, we take out that base, we get 3 outside the radical. That is lower than the index, so that's going to stay inside. That power matches the index, so I'm going to take an x out. I do not have to worry about absolute value because it's an odd index. That x, that power is less than the index, is going to stay inside. So we can have that. We took out the information where the power matched the index. Everything else that had a power that was less stayed inside. Now if that was an x to the 4th, I would break it down even further. Now when I look at this, there's generally a transcription error that I see. And you've had it as a cube root. Don't forget this. That's usually what I see forgotten. Because if this is now, this is saying square root, this is saying 1 of 2 equal parts. I want to be saying 1 of 3 equal parts. That's my simplified radical expression. Okay, so that's removing all nth powered factors from the item. Now, sometimes students will say, can these just cancel out? Can we just cancel? If the power matches the index, take out the base? Absolutely. Because think about it. If this is the nth root of a to the n, this is radical form. If I take this and change this to rational exponent form, we know that's the base, and the exponent is the power divided by the index. Well, if those are the same number, what happens? 2 divided by 2, 3 divided by 3, that just gives me my base. So if the power matches the index, they will reduce to 1, and I just take my base outside the radical. Okay, that will save the step of having to rewrite. All right. We'll give you your first. No, I won't give you your first you try problem just yet. We'll continue simplifying radicals, a little more involved in the next clip.